Ask a coding agent to code a stack and a queue. It will tell you that a stack is last in, first out, and a queue is first in, first out. Clean definitions, correct code. But it will not tell you why reversing them means Zepto double charges a customer for an order they cancelled. When you tap cancel order, 4 different microservices have to undo their work. If they undo it in the wrong order, the system breaks. Choosing between a stack and a queue for that cancellation pipeline is not a coding question. It is an engineering judgment call. Today you'll learn how to make it. 5 things you will own after this video. The cancellation cascade, the queue guarantee using Kafka, the stack rollback using last in first out logic, a live trace of a Zepto order cancellation, and the survival skill, the exact judgment call AI misses when designing event pipelines. If you watch this to the end, you will understand why these basic data structures are the foundation of distributed architecture. Let us build it. Here is the constraint. A customer places a Zepto order. The system executes 3 steps in order. Step 1. Payment service deducts 400 rupees. Step 2. Inventory service deducts 1 milk from the dark store. Step 3. Partner service assigns a delivery driver. The order is locked in. 10 seconds later, the customer taps cancel. This is the trap. How do we undo this? If a naive AI script just runs the steps forward again, refund payment, then restore inventory, then unassign partner, we have a race condition. The partner might already be driving to the store while the refund is processing. You cannot undo a process in the same order you built it. This is where stacks and queues stop being LeetCode problems and become system architecture. We use a queue, a first in first out structure like Kafka, for the forward path. The first event placed in the queue must be the first event processed payment, then inventory, then partner. But we use a stack, a last in first out structure for the rollback path. As the forward queue processes each step, it pushes a rollback instruction onto a stack. When a cancellation happens, we pop from the stack. The last step taken is the first step undone. Let us trace the live memory. As the order is placed, Zepto pushes commands onto the rollback stack. Push refund payment, push restore inventory, push unassigned partner. The stack now has 3 items. Unassigned partner is at the top. The customer taps cancel. The system starts popping from the stack. Last in, first out. First pop, unassigned partner. The driver gets a notification to stop driving. Second pop, restore inventory. The milk goes back on the digital shelf. Third pop, refund payment. The 400 rupees are refunded. By strictly enforcing last in first out, the system guarantees that no driver arrives for a cancelled order and no money is refunded for an item that is already shipped. The stack guarantees the correctness. Both are big O of 1 for inserts and removals. The difference is the ordering guarantee. Queue is first in first out. Stack is last in first out. In a production system, you use a queue for event streams like Kafka, where chronological order matters. You use a stack for the saga pattern, where distributed rollbacks must unwind in exactly the reverse order. If you're building state, use a queue. If you are unwinding state, use a stack. That is the judgment call. Before this video, a stack and a queue were just arrays with restricted methods. After this video, you know that a queue is how you safely process a payment pipeline, and a stack is how you safely reverse it without losing money. The engineer who says we need a last in first out rollback stack to prevent double charging is the engineer who designed the system. Everyone else just wrote the code. The engineer who understands ordering is the one who designs the system that works. Next Saturday, recursion and the call stack. What happens when an AI writes a recursive function without a bounded depth? It creates a ticking time bomb that takes down the entire order service. See you Saturday. Subscribe to ByteLearn for the complete DSA survival series. One judgment call every Saturday. Hit the bell. Question: have you ever used a stack to implement an undo feature? Tell me how it went in the comments.